In this video, we're going to talk about how to convert between degrees and radians. And then once you're in radians, we're also going to talk about how do you find that arc length and the area of sectors when your angle is in radians. And then we've previously talked about how to find those arc lengths and areas when your angle is in degrees. So we'll review that today as well. So the first thing we need to know is what is that conversion formula? So to be able to convert between degree and radian, degree is based on 360 degrees in a full circle. So if you spin a full circle, you've done 360 degrees. Radian is based on the circumference of a circle. And specifically, it's the circumference of a unit circle. That means a circle with a radius of 1. So if you notice on this first thing here, like if we go pi radian, so half of a circle, because remember the circumference of a circle is found by taking 2 times pi times the radius, and we're on the radius of 1, so the full circle, 360 degrees, so 360 degrees converts to 2 pi radians. Which means that half of 360 degrees, or 180, would convert to half of 2 pi, or just pi. That means 1 radian is the same as 180 degrees divided by pi. Or in this case, it's about 57.3 degrees. So every radian is about 57.3 degrees. Well, let's talk about this conversion. So we use theta to denote our unknown angles. And then we have this little d and this little r. The little d represents degree, and the little r represents radian. So it depends on which way you want this conversion to go. If you have the degree and you want to convert to radians, you would put the degree measure into this angle right here, into this theta, and solve for this theta. Likewise, if you had the radian and wanted to convert to degrees, we would put our angle here and then solve for this one. The purpose of converting to radians is a lot more advanced math classes use radians, use that circumference idea to deal with measurement. Because especially like when you get into calculus, you want to deal with a linear type measurement when you're finding rates instead of this arbitrary based on 360 degrees. So let's do a practice problem. Find the degree measure of negative 1.5 radians in exact form and in decimal form to 4 decimal places. Once again, think back to what our conversion was. So we had theta in degrees was over 360 degrees. Over 180 degrees. Equals our theta in radians over pi. So right now I'm given 1.5 radians. So I'm going to put this negative 1.5 in for my radian measure because I want to find the degree. So I'm going to say, okay, theta in degrees over 180 degrees equals negative 1.5 radians over pi. Now I need 2 answers. One of them is going to be the exact form and the other one's going to be the decimal form. So the exact form I'm going to work with first. When you're solving this is a proportion, to cross multiply and divide, or cross multiply and solve for the unknown. Well, you don't want to multiply or divide pi through because pi is an irrational number, so you cannot get an exact form if you multiply or divide through pi. So what you would do instead is you would just leave it in terms of pi. So I'm going to cross multiply. So I'm going to have this direction. So I'm going to have theta degrees times pi equals negative 270. So then I would divide by pi. So theta in degrees equals negative 270 divided by pi. This right here is my exact degree form. Now to find my decimal approximation to 4 decimals, I would actually do that negative 270 and divide it by pi. And I'd end up with negative 85.9437. 9437 degrees. So I have both forms. So here's one form, here's the other form. So the conversion is really not that hard to use. You just take some practice to get used to it. So let's try another one. So I'm given the radian, find the radian measure, and I'm given the degree measure. So I'm coming up here again, and I'm going to put this into the degree. So I've got 44 degrees over 180 degrees equals my theta in radians over pi. So I want my exact form. And the decimal form. Sorry, my tablet's having some issues. All right, so with the exact form, I can once again cross multiply and divide. So I'd have 180 times theta r Ooh, it does not want to work now. So 180 times, let's see here. Must be losing my conversions here. So instead, we're going to type it. So 180 times your theta and r, equals 44 times pi. So then I would divide by the 180 to get that theta. So my theta is going to equal 44 pi over 180. If I do 44 pi over 180, so I could definitely get a simplified fraction here if I think of this as 44 over 180. So if I do 44 divided by 180, and that's going to be 11 over 45. Let's see if it lets me write. Nope. All right, so we're going to do this way. So we end up with our theta in radians equals to 11 pi. And you could leave the pi out front. You could do it kind of at the end. That's up to you. 11 pi over 45. That would be your exact. So then your approximate, you would actually go from this point and type it into the calculator. So 11 times pi divided by 45. Your approximate would be about 0.4 decimals. So we go 0.7679. This is going to be what our approximate is. So then the question is, how does your calculator do this? Well, your calculator, if it doesn't come out exact, so if you notice both of these, their approximates were not exact answers. Your calculator will not always find the exact unless it's a nice number. In this case, it would find these approximates, but wouldn't always find the exact. So here's my recommendation if you want to see how your calculator does this, is I would look on your calculator and do a Google search for YouTube. Convert between radians and degrees on a TI-84 or whatever calculator you have. There are all kinds of videos that walk you through the whole process of how to do this. So that is converting between radians and degrees. And the next video we're going to talk about is arc length and areas of sectors.